Welcome to The Explainer. Today, we're jumping in a time machine and heading back to 1996. Now, we're not looking for the first smart contract in action, but for its original blueprint. We're going to dig into the foundational vision of computer scientist Nick Szabo, who dreamed up this whole idea of smart contracts more than a decade before blockchain even existed.
All right, so here's our game plan. First, we'll see what's wrong with old-school paper contracts. Then, we'll look at a brilliant analogy, the vending machine. After that, we'll get into the 4 pillars of design, check out the cryptographic tools needed to build them, and finally, see how it all comes together with smart property.
So first up, contracts beyond paper. Look, before we can really get why smart contracts are such a big deal, we have to talk about the problem they were meant to solve, the problem with the paper promises we've been using for centuries.
Let's start with the big question Szabo was asking himself. Why are the contracts that run our entire world so clunky? They're slow, they're expensive, they're just inefficient. He had this conviction that the answer wasn't to hire more lawyers, but to build better technology, a way to use computers to get around our very human limitations.
And this right here really lays it all out. On the one hand, you've got paper contracts. They cost a ton of money and time. They're filled with confusing language, and worst of all, if something goes wrong, you've got to drag everyone to court. Szabo's vision, the smart promise, was the polar opposite. He imagined agreements that were automated, crystal clear, and this is the magic word, self-enforcing.
So, self-enforcing, that sounds great, right? But what does it actually look like? Well, that brings us to Szabo's key idea, the analogy that unlocks this whole concept, the humble vending machine.
Let's go straight to the source. This is Szabo's original definition from 1996. Okay. A set of promises, specified in digital form, that part makes sense. But it's the next line that's the real game changer, including protocols within which the parties perform. That means the rules aren't just written on a piece of paper somewhere, the rules are baked right into the system itself.
So, how do you explain this wild new idea to people? Well, Szabo was brilliant. He just pointed to something we all use every day. He called the vending machine the primitive ancestor of the smart contract. Think about it. It's a contract made of metal and glass, it physically holds the property, the snacks or drinks, and it automatically enforces the deal.
And the logic is just perfect, isn't it? Step 1, you make good on your promise by putting in a coin. Step 2, the machine, the contract, verifies you did it right. And step 3, the machine automatically carries out its promise by giving you your stuff. There are no lawyers, no arguments, just a simple, direct, automated agreement.
Okay, a vending machine is a simple model. But how do you take that core idea and build more complex digital agreements? That's where we get to what Szabo called the 4 pillars of design. These are the rules of the game.
Szabo said any good smart contract needs 4 things. First, observability. Can everyone involved actually see what's happening? Second, verifiability. If there's a dispute, can you prove what happened? Third is privity, basically privacy. Are the details kept secret from the outside world? And last, the big one, enforceability. The contract should be designed to enforce itself, so you almost never need to call in a referee.
This all sounds fantastic in theory, but how do you actually build it? What are the digital nuts and bolts? Well, that takes us to the cryptographic toolkit. This is the tech that makes all those principles possible.
This quote really gets to the core of digital security. It's not like a physical lock you can pick. The security of a smart contract is built on math. It's based on the sheer impossibility of guessing a truly massive random number. It's that mathematical obscurity that creates a bedrock of trust in a digital world.
So, the first and most important tool in this whole kit is public key cryptography. Now, instead of having one secret key you have to share, this system gives everyone 2 keys. A public one you can give to anybody, and a private one you guard with your life.
The classic analogy here is just perfect. Think of your public key like a mail slot on your front door. Anyone in the world can come by and drop a secure message through it. But only you have the private key to unlock the door and actually read what's inside. It's a beautifully simple one-way street for secure communication.
Now, building on top of that, you get digital signatures. And it's so important to get this right, this is not a scan of your handwritten signature, not even close. Think of it more like an unforgeable digital wax seal. It's a chunk of math that proves, beyond any doubt, that your unique private key was used to sign off on something. It verifies who sent it and that it hasn't been tampered with.
Okay, so we've got the theory and we've got the tools. Let's put it all together. What happens when you apply all this to stuff in the real world? This is where it gets really mind-bending. This is when property gets smart.
And here it is, Szabo's most famous example, the one that makes his whole idea just click, the self-repossessing car. Yeah, you heard me right. He imagined this back in '96. Forget about a loan agreement being a stack of papers in a dusty file cabinet. Instead, what if the contract was a piece of software living inside the car's computer?
And here is the absolute kicker. If the owner misses a payment, the contract doesn't need to send a letter or call a repo man. No, the contract itself takes action. It automatically cancels the owner's digital key and gives control of the car right back to the bank. The enforcement is literally built into the property.
You see the huge shift here, right? Enforcement goes from being reactive, chasing someone down after they've broken the rules, to being proactive. The second a payment is missed, the car just stops working for the owner. The code isn't just a record of the agreement anymore. For that car, the code is the law.
So, when you step back, it's pretty amazing. This wasn't just some vague musing. Szabo laid out the whole thing, the problem, the design principles, the tools, and even real-world examples. It was a stunningly complete blueprint for a future that was, at the time, still more than a decade away.
And that leaves us with one final powerful question to think about. Szabo's blueprint was almost perfect. It had everything, except one thing: a place to run these contracts. You needed a neutral, decentralized network that nobody controlled, where the code could execute with absolute certainty. And that, of course, is the piece of the puzzle that blockchain technology eventually provided. It created the trustless stage for these smart contracts to finally come to life. So now that our agreements can literally become algorithms, what are the real limits? If our promises can become code, what can't be automated?